Hi everyone, my name is Ege, and in this video I'm going to show you the assignment 5. The goal was to build a generative adversarial network algorithm that can generate handwritten digits. Let's start. Before showing the code, I would like to talk about the gen. A gen has two neural networks that compete against each other. The first one is called the generator. What it does is that it's create a fake images from random noise, and the second one is called the discriminator. Its job is to look at an image and decide if it's real or fake. Both of them they train together, and the generator tries to fool the discriminator, and the discriminator tries to catch the generator. Over time, both get better and better, and the generator ends up creating very realistic images. Uh, the tutorial gave us a gen that used MLP, which means it's used simple linear layers. And our job in this assignment is to replace those layers with CNN. CNNs are much better at understanding images because they look at regions of the image instead of just individual pixels. And everything else, the dataset, the training loop, the optimizer, stay exactly the same. Let's start with cell 1. In cell 1, I import the torch and I import the necessary libraries, like NumPy and plot, that related stuff. I ran everything on GPU and overall it took me like 10 minutes to run all of the codes. Alright, let's start with the generator. So generator starts with a linear layer that takes 100 random numbers as input. Then it reshapes this into a 7 by 7 image with 128 channels. After that, it uses upsample layers to make the image bigger. First to 14 by 14, then 28 by 28. As you can see, like the 14 by 14 and the 28 by 28 with the convolutional layers. And convolutional layers learn the details and the textures of the digits at the end of the tangent, inverse tangent layer activation, and it brings the pixel values between -1 and 1. And the discriminator does the opposite of what generator is doing. It takes a 28 by 28 image as input, and it passes it through 3 convolutional layers that look for edges, shapes, and patterns. Then the pooling layers, as you see here, like those are the convolutional layers, like 3 convolutional layers, and then max pooling layers. Pooling layers reduces the size, and finally we have 2 linear layer that uh, it counts the single number between 0 and 1, and where 1 means real and 0 means fake. Let me talk about the training and learning rates. When I first run the model, I had a problem called like mod collapse. Like after 10,000 epochs, the generator was only producing the number 1, and it got stuck and forgets about all the other digits. I fixed this with slowing down the discriminator's learning rate from 0.002 to 0.0005. As you can see in here, my generator learning rates are 0.002, but the discriminator learn is around like 10, 20 times smaller than the generator learning rate. And I also changed this value from 1 to 0.9. This stopped like discriminator from becoming overconfident because like once you give like 1 instead of like other numbers, it thinks that everything it thinks valid is valid. So I don't think it is like helping the code too much. So instead of like keeping it as a 1, I just changed it to 0.9. I ran the code for 10,000 epoch, and let me show you the results real quick. Sorry. Um, Let me show you the first 100 epoch. As you can see, like it is so hard to identify any digits. It is blurry. Maybe this might be 6, but I'm not sure. Um, let's pick some like between like 5,000. So it's getting like better. Like we can identify 5 easily, and it gets more like thin than like thick. Uh, like 0 is nothing. 100 looks way better, 5,000 is better, and let's go the latest one. So latest one is I think it's pretty nice. Like I can easily see like 70942661429257498 3 I guess 19161. So overall, like there are some variety in the digits. Like I can easily see like most of the digits, and it looks like a handwritten digit. So I'm overall happy with the results. Thank you for listening to me, and this is the end of my assignment.